My name is Perry Thostison. I'm Assistant Operations Manager here at Lake Red Rock. The program areas that I'm responsible for include environmental stewardship, real estate, and flood risk management. This project that we're talking about today is involving the development of fisherying ponds. And we've worked with the DNR and Central Iowa anglers for a couple of years in trying to develop some sites for fisherying ponds. Fisherying pond is a pond, of course, that is used to help raise fish from a fry stage to a fingerling. Fry is about a 1/4 inch long, and then a fingerling is about the size of your finger, or about 2 to 3 inches. By doing that, we can increase the survivability or the getting a fish to the table from 1% at a fry stage to about 30% at a fingerling stage. So there's a huge advantage by allowing them a little bit longer time to grow and develop before they're put into a large body of water like Lake Red Rock. And we work with the committee, with the DNR, Central Iowa Anglers, Red Rock Lake Association, and some other folks to identify some places for these fisherying ponds. A number of them have their particular advantages and disadvantages. Of course, we need to be close to the water and have a good water source to help fill them. This particular site is the Wallachuk former sewage treatment lagoons. Of course, originally it was built in 1972 to treat sewage from the Wallachuk campground. We went on a commercial sewer in 2011, and they're basically retired after that. We allowed them to grow weeds for a couple of years, and then wanted to repurpose these lagoons to help raise fish. Obviously, there's some existing infrastructure here that would be quite expensive to build, and we'd have to do something with them either way. So by repurposing them for raising fish, we get a huge savings in terms of some infrastructure development and repurposing of a former structure. So we worked with the STEM student, or STEM intern, that stands for the science, technology, engineering, and mathematics. He was a science teacher out of Des Moines, and his purpose for working with us that summer in 2012 was to help come up with a plan and a way to repurpose these sewage treatment lagoons so we can use them for raising fish. His name was Gary Morris, and he did a really good job of coming up with a plan for us. And we're now in the process of trying to implement that plan. In the meantime, we worked with Red Rock Lake Association trying to get some grant money to come up with some of the other infrastructure costs to continue with this repurposing project. And we're able to obtain a grant from a handshake program that's within the Corps of Engineers, an extra funding source that helps fund special projects like this. And so we were awarded a $35,000 grant that will help pay for some of the plumbing and other infrastructure and things that we need to do here. That includes the construction work in terms of reshaping the ponds, buying plumbing to be able to drain the ponds, and putting on road and gravel surfaces down to the pond and down to the lake, and purchase or rental of a pump. So it's quite an elaborate project, and right now we've got to the point where we've got the pond shaped. We've got them prepped and ready to go for the placement of the plumbing, and we've just recently built a fish kettle that we partnered with on the cost and construction with the Red Rock Lake Association. This is the former sewage treatment lagoons. There's two cells. There's one on the left and there's one on the right. And the fish kettle, the structure that we use to help drain the ponds and retain the fish, is a concrete structure that you can just barely see out of between the piles of dirt there. Both sides encompass about a ½ acre. In that it has a bentonite lining so they won't leak. As part of that design, I guess that's one of the advantages of using a repurposed pond like this, is that it's already had as a design and that's incorporated into it so it doesn't leak.
Okay, that's a good idea.
We're going to fill the ponds by using lake water, and if you look to the right down here at the fence, where the fence kind of takes a dip, that's where we intend to build a small roadway down to the lake edge, and it would be accessible at most lake levels. We would place a pump down there and then pump water from the lake into these ponds. The combined water level or amount of water in the two ponds is about 1.5 million gallons, and that should give us about 3 to 4 feet of water in both cells. One advantage of repurposing a sewage treatment lagoon like this is that the original design that was made in the 70s had a bentonite liner in them to help prevent them from leaking. That could be a huge advantage in terms of any losses through the soil and retaining the water that we do pump into the cells, which is another huge savings there. We hope to raise bass, hybrid bass, walleyes, catfish. Those are the primary species that we're identifying now. They're very popular game fish here at Lake Red Rock and very workable in fish rearing ponds. After about 4 weeks of being in these fish rearing ponds, perhaps as long as 6 weeks, we'll drain the water out through the kettle and strain out the fry and be able to count and measure them and get some data collected for them. They'll then be transported with a vehicle and a trailer that's we're working with the Red Rock Lake Association to acquire and develop, and that would also involve some volunteer efforts from the Red Rock Lake Association members, Central Iowa anglers, and other folks to help with this rearing process and then the transportation and placement into the lake. And I believe the Lake Red Rock Association has gotten a grant for the purchase of a tank and other parts that will help make the hauling tank a workable and viable solution to move the fingerlings around to the different parts of the lake. We anticipate being able to add, say, a couple hundred to 400,000 fry per cell. There's a certain amount of predation that might occur either from amphibians or birds or just cannibalization from the fish. So we're not quite sure exactly how many we may get out. There are some losses from those sources, of course, but by getting them to a 30% survival rate, over 1% still allows a huge influx in the number of fish that could be released into the lake and then get into a fisherman's table to do. But they've talked about maybe doing an experiment, maybe keeping some in the pond and then raising them at a little bit longer time period. Some of those fine points in terms of that development haven't been worked out yet. Ben Dow with the fisheries biologist with the DNR I guess has some ideas on that, but what we're going to do absolutely, I guess I don't know. In terms of that data collection, or at some point they'll be released. We do hope, I guess, another advantage of doing this with 2 cells, if everything works well, we're hoping that we can also raise 2 crops of fish each year on each cell. So potentially we'd be adding water in, say, late March, adding fry in early April, releasing the water and catching the fingerlings in late April, early May, and then refilling the ponds in mid-May, and then adding additional fry to the ponds, and then catching those and releasing them in the June time period. So we're hoping to be able to get a 2 crop sequence going with these fish rearing ponds. If everything goes well, it is our long-range plan. It'll be part of our master plan to develop additional fish rearing ponds elsewhere. This kind of versus just releasing directly into the lake, which is kind of where we started from. They could flow directly to the lake, where you've got a lake level as much as Lake Red Rock. The success rate of this and any subsequent ponds may determine the ultimate number, but I guess that's kind of what we're looking at right now, about 10 acres of fish ponds. This is a fish kettle. It's basically a small concrete foundation. It's based on a design that was developed at Saylorville Lake. They built one of the first fish kettles that I'm aware of in Iowa. It's basically about 42 inches tall. It's got an 8-inch slab, and it's got a 2-foot hole on the upstream side that allows for the plumbing from the fish rearing cells to enter on this side. We would develop partitions on the inside and a screen to help slow down the flow and regulate the flow, and then be able to screen out the fish. And then, of course, this is the outlet side where the water would drain down into the lake. And again, the Lake Association was very instrumental in helping get this put together in terms of cost sharing and also payment with the contractor. Each cell will have its own screw gate or a way to open and close the thing. That's where the control structure, if you will be located on the inside of the pond.
Mm-hmm.
And so when it comes time to release the fish, then we'll just turn the crank, open the gate, and release the fish.
And you've got enough fall from here to the kettle that you will drain it then?
Yep. It should. I think it's a little over a foot, and that's enough fall where it's a gentle release, and so the fish won't get banged around and beat up so bad. And it'll allow us to still efficiently get the water out of there. So if there's about 750 gallons on each side, it'll take a little while to get through there, but according to the design, it should be a perfect amount of fall and rate, so you're not trying to strain fish all day long,
Yeah.
or injuring the fingerlings when they come out through the pipe.
But it will drain the water.
Yep.